In this lecture, we're going to learn about mutable objects. And this is a mechanism we have in C++ to violate const correctness. If you look at our class here, we have the good old dog class we have been using all along. And inside we have a function, which is printful here. It is a const member function, so we can't really modify the member variables of our object in any way. But sometimes you want to be able to modify some member variables, for example, for debug purposes. Suppose we want to know how many times this printful function was called in our program, and we really need this. So C++ allows us to mark some member functions as mutable, and that means for that member variable, it's going to be allowed to violate const correctness and modify that member variable even from a const member function. So how can we do this? This is really simple. All you have to do is mark your member variable as mutable. You just have to put the mutable keyword in front of the declaration of that member variable. And from this point on, if you modify this member variable from a const member function, you're not going to get a compiler error. And again, this is not recommended. And I have to say, I have never used this in my career as a C++ developer, and I have been doing this for many years. So I guess what that says is that you shouldn't really use this way of doing things unless there is a very compelling reason for you to do so, because it's going to make your code less understandable by other C++ developers. Now that we have seen this, let's head over to Visual Studio Code and play with this a little more. So here we are in our working folder. The current project is Mutable Objects. We're going to grab the code from the previous lecture, dangling pointers and references, and I think we can use this as a starting point. We're going to grab VS Code, the folder. We're going to grab the classes and the main function. We can grab everything, and we're going to use those in this lecture here. So make sure you have the starting files. If you don't want to copy them from the previous lecture, you can get the code for this lecture in the resource section of the lecture where you are watching the course here. So for now, we're going to open this little guy in Visual Studio Code. Let's do that. And we're going to have our class in two files, dog.h and dog.cpp, and we're going to have the main function here. What we want to really see is the mutable keyword, and we're going to be doing that mainly in the class. So let's go to dog.h, and I think there are a few things we can remove now. For example, we can get rid of the getters and setters here. We don't need them anymore in this context. Let's go in the dog.cpp file and remove them. Let's do that. And we are going to be working on our printful function. Before we do that, we're going to add another member variable, which is going to count how many times the printful function was called. And I don't think we need these two functions here. They were just there to show you how things can go wrong in the lecture on dangling pointers and references. But now you know that. So let's take them out. We're going to set up a member variable. It's going to be size t, and it's going to say printful count. We're going to initialize this to 0. And now we really want to modify this variable from the printful function here. But if we do that now, let's do that. We're going to increment that member variable. We're going to say printful count, and we're going to increment this. And the moment we do this, you see that we get a compiler error because we can't modify the member variables of this class from a const member function in any way. This is going to violate the const correctness of the class object here. But what we can do if we really want to do this is to mark this member variable as mutable. Let's go back in our class definition, and we're going to add the mutable keyword in front of our member variable here. This is the syntax. And the moment we do this, if we go back, you see that Visual Studio Code is happy about this now. We are allowed to violate the const correctness of this object. And this is really, really confusing. Again, don't do this in your real projects unless you really, really need to do so. Some people that say that they have used this, it was only for debug purposes, but personally, I have never used this feature in my career as a C++ developer, and I have been doing this for almost 10 years. So don't really do this. It's going to make your code less predictable And other developers are going to have a hard time understanding how your code is behaving, because anybody is going to expect a const member function to never modify the member variables of your class. Okay, now that we know this, we can add the printf count information in our output here. I think we can push this to the next line and add another line that says print count, and we're going to say that. I think we could, what did we do? Let's type this ourselves, and we're going to then add this. I think we can do that, and this is going to work. I think we should change printf count to m printf count because it is a member variable. The m here is going to mean that it is a member variable, and I like to really make my member variables self-documenting in this way. So I'm going to grab this, and I'm going to say increment this, and I am going to print that out here. And this should be all we need here. So now we can go in the main function and say dog1 printful. And if we build, we're going to see the output. Let's do that. We're going to use GCC. The build is going to be good. Again, we are allowed to modify a member variable of a class from a const member function because we marked the member variable as immutable. Let's go back to main. And we're going to bring up a terminal so that we can run this. We're going to clear and run rooster. And we see that print count is 1. If we print again, we're going to say dog1 printful. And if we build again, we're going to see this run. We don't want to split our terminal. Let's bring up a terminal. We're going to clear and run rooster. And let's build. We're going to run the task to build with GCC. This is going to build fine. We can clear and run rooster. We can see that the count is going up. Even if we do this in a loop, it is going to work. So for example, we can do a for loop for size ti, and we're going to start from 0. We're going to go as long as I is less than 10. Why not? And we're going to put in our incrementation part, and we're going to say dog printful, dog1, we should say printful, and we're going to be calling this function 10 times in this loop here. So for the first guy, we're going to get the print count of 1. For the second one, we're going to get 2, and we're going to do 10 more. So we should print for 12 times here. So let's do that. We're going to build with GCC, and the build is good. We can clear and run rooster. Now you see that the print is going from 1 all the way to 12 because we're calling the print function 12 times in our main function here. And again, this is possible because we marked our member variable as mutable in our class here, and we are able to increment it from a const member function. One trick we used here is that we print it after we increment. So the first time we go in the function, we're going to increment mprintf count. And if you go back to the header, you see that we initialize this to 0. So if we increment it for the first time, we're going to get a 1, and then we're going to print that out. If you print before you increment, you're going to start from 0, and that's probably not what you want. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about structured bindings. Go ahead and finish up here and meet me there.